Pass our test back on Friday, and you can take a look at your test. So we're in section 8.3, and we're talking about sine, cosine, and tangent ratios. So let's remember, back in chapter 7, the one we just finished with, so it wasn't that long ago, we talked about similar polygons and similar triangles. So I want to draw a picture here of two triangles, and I want to see what we can figure out about these. So we're talking about, chapter 8 is all about right triangles, so these are two right triangles. I'm going to say this angle and that angle are congruent. So what do we know about these two triangles if these two angles are congruent? The third angle has to be congruent. And what do we know about the triangles then? They're not necessarily the same size, so they're going to be similar. The triangles are similar. And they're similar by angle. And I'm going to call the sides on this triangle capital A, capital B, and capital C, and call these small a, small b, and small c. Because the triangles are similar, what do we know about their size? They're different, but they're related somehow. They're proportional. And I misspelled ratios here. R-A-T-I-O-S. So we can write a ratio with their sides. So I'm just going to pick a side, and I'm going to say, for example, A over C on the big triangle equals A over C on the small triangle. And it doesn't matter what this angle is, as long as these two are the same. Those ratios are always going to be the same, no matter how big, no matter how small the triangle is. If we know that this angle in the right triangle, those ratios are always going to be the same. Well, because using ratios and triangles is convenient and it comes up a lot, we give ratios in right triangles special names. And that's what the sine and cosine and tangent are all about, is these names that we give the ratios of sides of right triangles. That's really all that trigonometry is about, is ratios of sides of right triangles. If we know that the angle, we have a specific angle, those ratios are always going to be the same no matter how big or small the triangle is, as long as it has some specific angle. So on your graphic organizer, let me draw a picture that kind of matches your graphic organizer there. I want to start that off. So on your graphic organizer, your triangle looks like so. And they call this, the capital A now is the angle, capital C is the angle, capital B is the angle, and that is our right triangle. And the way we normally label triangles is if we call the angle a capital letter, we call the side across from it the small letter that matches. So that's angle A, that's side A. Angle C, this is going to be side C. Angle B, and this is going to be side B. So we give these ratios that are always the same for a specific angle, we give them special names. The first one is called the sine of A. We read the sine of A. The sine of an angle is the opposite side divided by the hypotenuse. And by opposite, I mean the side that's all the way across the triangle. And the hypotenuse is always the hypotenuse. We never call the hypotenuse anything other than the hypotenuse. So on the triangle that we have there on our graphic organizer, the one that I've drawn here, the sine of angle A, what side is opposite angle A? All the way across the triangle. side A. And the hypotenuse is C. That's what the sine of an angle is. The opposite side of the triangle divided by the hypotenuse of the triangle. So let's look at sine B. Here's angle B. What side is opposite side B? Or angle B? Side B. Opposite over hypotenuse. And if we know this particular angle, that ratio is always going to be the same no matter how big or small the triangle is. So that's our first special trig ratio. We call the sine a trig ratio. Let's look at the cosine. That's what COS means, cosine. The cosine is the adjacent side. And we've said that adjacent means next to. Adjacent over the hypotenuse. So we're just naming that ratio. We name it the cosine. So on our graphic organizer, they label the sides for us. So what is the adjacent side to side A? What side is next to angle A? B. The hypotenuse is always the hypotenuse. So the cosine of A is B over the hypotenuse C. So let's look at the cosine of B. Here is angle B. What side is adjacent to angle B? A. And the hypotenuse is always C. So that's how we find the cosine of our angle. Find the adjacent side divided by the hypotenuse. And then our third trig ratio is, we call the tangent. And that's what this means. TAN is tangent. The tangent is the opposite over the adjacent side. And I should put an angle in there, tangent of A. Tangent of A is the opposite over the adjacent. So on our graphic organizer, pull this back up here. Which side is opposite angle A? C is always a hypotenuse, so that's going to be A. And the adjacent side? B. Adjacent means next to. Tangent of A is A over B. And I'm going to go over here. Tangent of B, so there's angle B. What side is opposite angle B? Side B. And what side is adjacent to angle B? A. And that's all there is to finding sine, cosine, and tangent if we know the sides of the triangles. We just make the ratios. Opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. And if we know the angle, those ratios will always be the same, no matter how big or small our triangle is. Because those triangles are going to be similar. So questions on what we did here to fill in our graphic organizer. All right, so at the bottom there, it says Chief SOHCAHTOA. SOHCAHTOA is a way to remember which sides to put together for the ratios for, and I forgot my angle here for cosine. It should be cosine A. SOHCAHTOA tells us what sides to put together to make our ratios for sine, cosine, and tangent. So let me write that out. What SOHCAHTOA means. SOHCAHTOA means the sine of the angle is the opposite, and I'm going to use our abbreviations, over the hypotenuse. Opposite divided by hypotenuse. Cosine is adjacent over hypotenuse. and tangent is the opposite side over the adjacent side. So that's what SOHCAHTOA is. SOHCAHTOA is just a way of helping us remember which sides to put together for the ratio. So what I want to do is I want to do one example where we're picking out these ratios where we know the sides of our triangles, and then what we're going to do is use sine, cosine, and tangent. Our calculator will calculate sine, cosine, and tangent ratios if we know the angle. Our calculator will tell us what the ratio is, and we can use that to solve problems. So let's look at an example with a triangle, and we'll pick out our sines, cosines, and tangents. So I'm going to call this angle A. The other way you'll see these angles a lot when we talk about trigonometry is we like to call angles theta. This little symbol is a Greek letter called theta. And I'm going to say this side is 3, this side is 4, and this is a right angle. So if we know these two sides are 3 and 4, what's the hypotenuse going to be? 5. This was one of our special Pythagorean triples. So this is going to be a 3, 4, 5 triangle. And we're going to find our sine, cosine, and tangent of A. So sine of A. What I'm going to suggest that you do with these kinds of problems is label the sides, kind of like we did for the Pythagorean theorem and for special right triangles. We're going to label them opposite, adjacent, and hypotenuse. So if this is angle A, if this is the angle we're looking at, is side 4 opposite, adjacent, or hypotenuse? Side 4 is the adjacent side. That's next to the angle. Side 5? Opposite, adjacent, or hypotenuse? That's our hypotenuse. It's opposite the 90-degree angle, and it's the longest side. And that leaves this to be the opposite side. Now we just pick out our ratios. Sine of A is opposite over hypotenuse, 3/4. So for this particular angle, no matter how big or small the triangle is, the ratio is going to be 3/4 for that angle. Cosine of A. So SOHCAHTOA tells us the cosine is the adjacent over the hypotenuse, so that's going to be 4/5. Yes? Oh yes, 3/5. I picked out the wrong one for that part. 3/5, thank you. Because 5 is our hypotenuse. And then the tangent of A is the opposite over adjacent. That's what I wrote over here. 3/4. And that's how we find our sine, cosine, and tangent using SOHCAHTOA. Not necessarily. We could do it for B here as well. We call that angle B. Then we could find our sine, cosine, and tangent of B. We won't do it for the right angle. We'll always do it for one of the other angles. So what's the sine of? Let me circle side. This one in blue and this one in red. Just to color code this. So what side is opposite angle B? 4. So this would be the opposite for angle B. What side is the adjacent side for angle B? Adjacent means next to, so this would be adjacent, and the hypotenuse is always the hypotenuse. So the sine of B is the opposite over the hypotenuse. So the sine of B would be 4/5. Cosine of B, adjacent over hypotenuse, 3/5. And the tangent of B, adjacent, or opposite over adjacent, 4/3. And if you look at these, you'll see that the sine and the cosine are the same, and the tangent is flipped, and that always turns out to be the case. So we just, depending on which angle we have, we label the sides and pick out our ratios from that. All right, questions on what we did there? So label your sides, and then you pick out your opposite, the adjacent hypotenuse, make your ratio from SOHCAHTOA, and you're set. The other thing that we can do, the other thing that we'll do with trigonometry, is we're going to use trigonometry to find missing sides of triangles. So if we know the angle, our calculators will tell us the ratio, and we can use that ratio to solve problems. So I'm going to give you some steps for solving these problems. So our steps for trig problems. If you follow these steps, you'll always get them right. So we're going to label the triangle. And by label the triangle, I mean once we know our angle, label opposite, adjacent, and hypotenuse. Just like we did for right triangles when we labeled it ABC, and for special right triangles when we labeled it short, long, hypotenuse, or leg, hypotenuse. Doing the same kind of thing. Once we label our triangle, we decide which ratio to use. And by that I mean we'll depending on the sides we have, if we have the opposite and the hypotenuse, we know we have to use sine, because sine tells us about the opposite and hypotenuse. If we have the adjacent hypotenuse, we use cosine, because the cosine tells us about those two sides. So we decide which ratio to use based on what the problem tells us. Then we're going to write an equation. And our equation is going to look like one of these three. The sine of the angle. The problem is going to give us an angle. And the sine of the angle is the opposite over the hypotenuse. If we know the adjacent and the hypotenuse, we're going to write the cosine of the angle is the adjacent over the hypotenuse. And if we know the opposite and the adjacent, we're going to write tangent of the angle equals opposite over adjacent. So we'll write one of those three equations, depending on what sides of the triangle the problem gives us. Then we will solve for the part that we want. And our last step will be to calculate. And we're going to use our calculators for these problems. And if we follow these steps, do them all correctly, we'll always get the right kind of answer. We'll always get the right answer with these trigonometry problems. So let's look at a couple of examples where we are going to use our calculator to find missing sides of triangles. So questions on our steps. Okay. So let's work out a few examples. So here's our triangle for this problem. We know that this is a 30-degree angle. And let's make it a little different. Let's do a 32-degree angle. So we don't have a 30, 60, 90 triangle. So 32 degrees, and this is 12, and this is x. And our problem says to find x. So let's follow our steps, label our triangle. Is 12 the opposite, the adjacent, or the hypotenuse for this 32-degree angle? 12 is the hypotenuse. X, opposite or adjacent for this angle? Opposite. Now I say, what trig ratio tells me about the opposite and the hypotenuse? So I look at SOHCAHTOA. What which one tells us sine, cosine, or tangent tell us about opposite and hypotenuse? Sine. So since I have the opposite and hypotenuse, I'm going to write my equation. Sine of 32 degrees equals the opposite, x over 12. My calculator will tell me what the ratio is for the 32 degree angle. And we know that that ratio equals x over 12. How do I get x by itself here? How do I get rid of this 12 in the denominator? Multiply by 12 on both sides. Those cancel. Turn this around, I get x equals 12 sine 32 degrees. And then the last step was calculate. So I'm going to go to my calculator. So this is kind of a generic Texas Instruments calculator. So if you have a calculator like this, a couple things that you need to keep in mind. Your calculator should say degree up here. And if it doesn't say degree, you're going to change your mode to make sure it's in degree mode. If you're not sure how to do it when you're calculating these, I can help you out. We want to make sure our calculator is in degree mode. So I'm going to plug what I did, exactly what I wrote down. 12 times sine 32, enter. And I get 6.34. And I go back here. That tells me that x equals 6.34. Questions about what we did there? All right, let's look at another one. So here's my triangle for this problem. And we're going to say this is a 52 degree angle. And this is 8. And this is x. And we're trying to find x. So let's label our triangle. X, the side we're looking for, opposite, adjacent, or hypotenuse for this angle. X is the hypotenuse. 8, opposite or adjacent? Adjacent. It's next to the angle. What trig ratio? Now our question is, what trig ratio tells us about the adjacent and the hypotenuse? Cosine. So I'm going to write my equation. Cosine 52 degrees equals the adjacent, 8, over the hypotenuse, x. This is the trickiest kind of problem that we'll do in this particular section. This is as tricky as it gets. How do we get this x out of the denominator? Multiply by x. So I'm going to multiply both sides by x. Those cancel, and I get x cosine 52 degrees equals 8. Well, cosine 52 degrees is just a number. So my problem now says 8 times a number, or x times a number equals 8. How do I get x by itself now? Divide by cosine of 52 degrees. So these cancel. Anything divided by itself is just 1. I get x equals 8 over cosine 52 degrees. Now I go to my calculator. 8 divided by cosine 52. Enter. 12.99. Now I go back. X equals 12.99. And that's all I have to do. So I follow the steps. And this, having to multiply both sides by x, that's really as tricky as these questions get. Now when we were back here, and we had x times the cosine of 52 equals 8, I could go to my calculator right there and plug in cosine 52 and come up with a number for this. But if you do that, make sure you keep plenty of decimal places. Because if you round off too soon, your answer can get thrown off by quite a bit. That's why I like to wait until the very end to calculate. But you could plug this in and get a number here and work from there. Works just fine. All right, questions then? All right, let's look at another one. So here is my triangle for this one. My right angle, we'll call this a 47-degree angle, and we're finding x. So let's label our triangles, follow our steps. Is x the opposite, the adjacent, or the hypotenuse for this angle? Opposite. We're across the triangle, we're opposite. 7, adjacent or hypotenuse? Adjacent. What trig ratio tells us about the opposite and the adjacent? Tangent. So I write my equation. Tangent 47 degrees equals x over 7. This is an easy one. How do I get rid of this 7? How do I get x by itself? Multiply by 7. X equals 7 tangent 47 degrees. Now I can calculate. Go to my calculator. 7 times tangent of 47 degrees. Whoops, not 477. Enter. And I get about 7.51. Go back here. X equals 7.51. And just to point something out, 47 is pretty close to 45, right? And these two legs are pretty close to being the same length. Not quite, pretty close. So our answer makes sense. All right, let's look at one last example. Just want to make sure that for this one particular kind that we all feel good about it. And we're finding x again. So let's follow our steps, label our triangle. Is x the opposite, the adjacent, or the hypotenuse for the 62-degree angle? Adjacent? 9, opposite or hypotenuse? Opposite. Now we'll write our equation. Tangent of 62 degrees. Our calculator tells us that ratio is the same as the opposite over adjacent, 9 over x. How do I get rid of that x in the bottom? Multiply both sides by x. Those cancel. I get x tangent 62 degrees equals 9. To get x by itself now, to solve for x, this is just a number. So I can divide by that number. That divides, just gives me 1. So I get x equals 9 divided by tangent 62 degrees. Go to my calculator. 9 divided by tangent 62. And I get 4.7, about 4.79. So the homework for this section, where we'll either have all the sides of the triangle, and the question will ask us what's the sine of the angle, what's the cosine of the angle, and you're just making the ratio. Or we'll be solving for the missing side, and that's when we follow our steps, doing like we just did on these last 4 examples. And that's really all we have to do for this section. Not complicated, just making ratios. Our calculator will calculate these ratios for us. It has them all in its memory. All right, questions? Okay. Our homework. Page 510, 11 through 21, and then 40 through 45.